Hey there, how has your day been? And welcome back. In last lesson, you've learned how to open your first simulation, apply gravity to the world, load the objects, spawn your target object at a specific coordinate, and run the program with time. Before we start this video, if you are the new learner in PyBullet, I recommend you go watching part 1 first, or you can watch other creators' video as well. In this lesson, we are going to learn a few things, which are how to continuously fetching or getting your object's latest coordinates. As the simulation moves on, set your own initial camera position with your coordinates. Apply force in newtons to an object and apply mass to your object. These are what we will cover in this video. I will go through slowly one by one to make sure you can understand them. Now, let's get started. Let's begin with getting the object's coordinate in real time. How can we do that? To achieve that, we can use PyBullet's function called getBasePosition and orientation. This will output both coordinates and orientation. In other words, we will get x, y, z, and w. Orientation represents a full rotation in three-dimensional space, not a 2D angle, and PyBullet uses normalized quaternions to avoid gimbal lock. We will just throw away orientation first and focus on position, which is just simply x, y, and z. In this function, you need to pass the object's ID. If you go back to the soccer ball that we loaded before, you can see that it doesn't have any variable name. Try to give it any variable name and pass it into the parentheses. Next, since we know that this function will return x, y, z, and w, then we need to write two variables on its left, which are for the position and the orientation. You can name it to anything you want. And that's it. You can use a print statement to print out the three individual coordinates. If you want to make it look cleaner or prettier, you can absolutely do that. And there you go. You have the soccer ball's coordinates printing in your terminal. If you ever want to get the individual coordinate, like x, not y and z, you can do this. We know that it outputs a list with x, y, z in it, and I hope in basic Python you learned about index. In this case, x is at index 0, y is at index 1, and z is at index 2. You just write down the object's variable name and pass the index at the side by using brackets. Then the program will print out your target coordinate. Next, I'm going to teach you how to set your initial camera position in your 3D simulation world. It's really simple. You use PyBullet's function called resetDebugVisualizeRCamera and pass in 4 parameters. They are the camera target position, pitch, camera horizontal rotation, and distance away from the target point. Now, what do those mean? Well, firstly, camera target position. This is the exact 3D point x, y, z the camera is looking at. The camera will lock its focus onto this specific spot in the air, like 10 meters off the ground. Secondly, camera distance. This is how far away the camera is from that target point, measured in meters. Increasing this zooms out, decreasing it zooms in. Thirdly, camera pitch. This controls the vertical tilt of the camera in degrees. A negative angle like -30 means the camera is placed up high looking down at the target. Lastly, this controls the horizontal rotation around the target in degrees. A value of -45 rotates the camera to view the target from a diagonal 3/4 angle, angled between the standard x and y axes. And there we go. Let's run the simulation and test it out. Feel free to play around those settings. Now let's learn how to apply mass to your object. You can use PyBullet's change dynamics function. Inside this parenthesis, you need to pass into 3 parameters. They are the object ID, your object's link, and the mass, in kilograms. I will explain what those means. Firstly, the ball ID, this is the unique identifier of the target object in the simulation. Secondly, -1 means the specific index indicating the base link / root part of the body. Multi-link objects use 0, 1, 2, etc. for their attached joints / links. We stick to -1 if we want to target the base link. Thirdly, mass. This is the new weight of that part, which PyBullet always measures in kilograms. And here are the key side effects to know. When you change the mass using p.change dynamics, PyBullet automatically updates two other properties under the hood, which firstly is the inertia matrix. PyBullet recalculates the local inertia tensor for a sphere of that mass. Secondly, it is the activation. If the object was sleeping, deactivated to save CPU, changing its mass instantly wakes it up, so gravity acts on it immediately. If you run your simulation again, you might notice nothing has really changed, but the mass has been applied to your object anyway. To apply force to our object, we firstly need to determine whether we want to push the object once or continuously. What do I mean by that is if you write the force function outside the for loop, the object is only going to get pushed once. On the other hand, if you place the force function inside the loop, it will continuously applying force to it. To achieve this, PyBullet's function called apply external force, and you need to pass in 5 parameters inside the parentheses. They are the object's ID, which is the variable named that you have previously defined, object link, like we did for our mass application, how much force to apply, where or what position to apply the force, and what is it relative to. Firstly, object unique id. As we have learned before, this targets the specific object. Secondly, link index. This is what we have learned previously as well in the mass application. It applies the force directly to the base link, the root part of the ball. Thirdly, force object. It specifies the force vector in newtons. You can choose which direction to apply the force. For example, like x equals 10, y equals 0, z equals 0. Fourth, position object. This is the 3D position where the force hits the ball. And lastly, flags. This defines the coordinate system used to interpret the force direction and hit position. After that, run your simulation again. You will see PyBullet applies the force to our object. Feel free to adjust the force value to play around. And that's all for part 2 of this video. In the next lesson, we are going to focus on some slightly complex but also exciting features like controlling the object with your keyboard. In the future parts, we are eventually going to dive deeper about training a robot that looks initially disabled and transition it to a proper walking robot. After that, we can learn about even sophisticated features. See you in part 3.